afternoon, everyone. Today we are going to perform the experiment software part of the input and output characteristic of BJT transistor. Here we are going to have we are going to perform the current control characteristic of BJT transistor, and to determine the output characteristic of BJT transistors, the same apparatus what we required in the previous experiment. We are using the same thing, but here the new thing what we are going to use is the transistor BC135. According to availability of the software you can use. So let me share the screen with you. Already I have connected the circuit here. Share it. Sorry, share the thing. So so here we have the voltage source. From DC voltage source we are connected to the plus, okay, of the emitter, and negative of the emitter is connected to the 2 ohm resistor, and from here we are connected to the base. Here we will measure the base current, and here we will measure the collector current. From plus we are connecting to the from the emitter, and emitter to the collector of the transistor, and here this part is going and connecting to the ground. So here this is the circuit. As you can see in the circuit, you have a fixed 12 volt here. You can use the cable also, but you can fix. Okay, so let me the circuit first. Let us have the look of the tabular form. You can open the manual and you can check the tabular form. Here you have VC 12 volt. You will change the base current, and you will take the corresponding collector current. Okay, so base current here, let us say we have, okay, let us stop this, and I will just make it like increment of 0.05, okay, small increment. So the cursor, I will just bring the cursor here. No problem. So let me make it. So start with the circuit again. So here it is 0. For 0 it is showing 0. Okay, to make the correct, here the base current will set according to the multimeter. Will set the base current to the 0.2 micro. Okay, sorry, it's 0.2. Let me check again. It is 0.2 milliampere. So 0.2 milli means it will be 200 micro, right? So let us go back and set to 200 micro. So it is 300, 600. So let us move the cursor here. So it is 400. So approximately 200. Okay. This is 200 microampere, and the output voltage is 58 milliampere. Okay, so write the corresponding values in the table form. First is 58.561 milliampere. This is the collector current. Next, again go back and just change the value accordingly. This is for 400. For 400 it is 98.453 milliampere. Okay, so take the corresponding values till 3 milliampere. Okay, so this is for 0.2, 0.4 we have taken, 0.6, 0.8. This is 0.6, it is 135. 0.8, it will be, it is 2, 2, 2, 2, 2. Yeah, 158.737. Next it is 1 milliampere, approximately. Milliampere, so it is 206 milliamperes. Okay, we'll make it to it is 276, and finally we take it 3, right, so 364. So write down the corresponding values in the tabular form. So this is the first part. Output characteristic of the transistor. Now let us connect the second circuit. You can see the second part in the manual. Output characteristic of the transistor. So just go back to the circuit and let us check the circuit here. Okay, we have the circuit. So let us stop this and let us add the new workspace here, new design or workspace. So here, what you have here, it is you have 3 ammeters here and 2 supply same. So why we just will take the same thing. We just remove and connect. So we need here resistance of 6.8 kilo. So that's 6.8 kilo. So I need the resistance first thing. Next is 100 ohm. 100 ohm resistor I need here. Okay, I need 100 ohm resistor. Perfect. Next thing, I need 3 ammeters here and potentiometer, and the potentiometer 470. So let us go back here and search for the potentiometer. Here it is 400, 470. Okay, so let us keep here, and I need 3 ammeters here. 1, 2, and 3. Okay, and I need the transistor. What we used in the previous, we just use the same transistor here. Okay, and what else we need? We need the DC power. We will use the same interactive voltage here. Signal voltage source, DC interactive voltage 1. Okay, I will use the same DC interactive voltage again. I will use the same here also. Okay, so let us draw the circuit first. Here it is. We have 12 volt fix here. It is connected to 470, and from here it is connected to 6.8 kilo, and from here we have connected it is to ammeter, then transistor, and from transistor it is grounding, and here it is connected to the voltmeter. We need one voltmeter also here, and here the ammeter. From ammeter it is connected to the 100 ohm. Okay, so these all are connected to the common point. So let us start connection here. So this is voltage source. This is also voltage source. Here you are using. Okay, we need ground here. Sorry, I forgot to take the ground. That is the power supply. Ground. Okay. So let us start connection here. So this is the transistor. Between these two transistor, I need an ammeter, transistor, and this resistor. This is the base current, and from base current, we have to connect to the. I will change the direction of this potentiometer and this point. So it is messy here, so just move it properly at the proper distance. So 470 duty cycle, and this is my power supply, and this is 100 ohm resistor, and from 100 ohm resistor we have to connect to another supply. Okay, first we will take this supply. Okay, I will just delete this and I will use the DC supply here. Power source, DC power supply here, and finish. This is positive, which is connected to the potentiometer over here, and this is connected to the ground terminal, and this is also connected to the ground terminal. Okay, and this is also connected to the ground here. Okay, this is the first supply part done. Okay, here it is 12 volt fixed. No need to change this. We need to change the voltage of the collector. So I will use this some DC power, variable DC power supply here, and it's connected here. So here the supply is connected to the 100 ohm like this. This is move it properly. From 100 ohm, we want one ammeter here. I need an ammeter. Okay, and from ammeter, it is connected to this point, and this is working as an voltmeter. Okay, from this point, we connect to the ground. Okay, and this is just reverse it and connect it across the transistor at this point here and the common point. So here we construct our circuit. So let us start the circuit. It is grounded now. Okay. Let us make it 0, no problem. Start. So this is my ammeter, first ammeter. Just keep it down, and this is another ammeter. Just keep it with this, and this is my voltmeter. Keep it here. So now let us see the table form. So now we have collector voltage is fixed 12 volt, and now we are changing the VCE from 0 to 3. Okay. So by keeping the constant IB constant, IB is nothing but base current constant. Now how we keep base current constant with the help of this potentiometer what we are going to use. So but with the potentiometer what we can use, we can just fix the voltage. Okay, we can fix the voltage. Then we can vary the collector current from the variable supply what we have in the collector terminal. Okay, and we take the corresponding values here. Okay guys, let me start that reading here. Let me fix IB. Now this is my base current, so I will fix this IB to 0.2. So this is ammeter, and this is voltmeter, and this is ammeter. Okay, so I will change this voltmeter value IB value to 0.2. So we reverse it. So it is 0.2 means 200, right? Actually, we change this direction, right? Because of that, uh, we are increasing in this direction. So this value is decreasing here in the ammeter. You can see 200 micro still. So what we do, we change the percentage here. So increment percentage is 0.05. Okay, now it's so it's 200 micro. Exactly. Okay. So let us fix this value. This part as it is. Okay. No need to just see this. So now we have the base current as 200. Now what I will do, I will change the current from here. Okay, so now it is zero. So again, sorry, why is zero? We fix it to 100, 0.2 milli. Now no need to change it again. So now this is zero. The voltage is zero now. So what we do, we will change the voltage from 0.1 to 3. So voltage, what where it is, the voltage is here. Okay. Uh, voltage will be changed from 0.1. 0.1. So install the circuit and make the increment, small increment 0.05. So I can now start this. So it is 1 volt. It is 60%. So zero point 0.1 milli corresponds to, instead of, sorry, 0.1 volt corresponds to 100 milli, right? So we just further decrease this, so it will be 100, 100, 100. So this is almost 100 here, okay? This is 100 volt, and the corresponding output voltage current of the collector is 24.08. So let us tabulate the value for IB 0.2. The first value of the current is 24.098. So simultaneously, what you will do, you will just increase this value from 0 to 3. So zero point 0.1, next value 0.2, means it will be around 200, right? 200. It's around 200. So it will be to 44.325. 100. And next value is 0.3. So it will increase to for 0.4, it is 45.98. We need 0.4. Oh yeah, 0.3 we missed, right? So we'll make it for 0.3. Use the cursor here. It's 45 again. So as you can see, now at 0.3 it is 45, okay? And 0.4 it will be constant, okay? Now this transistor is working in the saturation mode, okay? Uh, from the active mode, it has transformed to the saturation mode. It is in the saturation mode. Now the collector current will be constant, 45, okay? And again, it is further to this 6, it is 46. Small deviation, no problem. Again, 8, 0.8 is 46. And for one more, it is also 46. So that means now the transistor is, after increasing from 24 to 44 to 45, it has become like this. Okay, so now the transistor is working in the saturation mode. So what next? What we'll do is, now I will just again change this resistor value to potentiometer value to 0.4. Make it 0.4 here. So fix, sorry, make it 0 here, and it is 4 in 0.4. Okay, small, just a small one. Okay, so now it is 0.4 milliamperes, and again repeat the whole thing from 0. Okay, it is 0. It is a very small voltage here, and the current is 39 point something. Okay, just let us make the first value. Just let us fix this to first 100 millivolt. That means it will be 0.1 volt. This is the cursor here. It's nothing but right arrow in your keyboard. It is 100, so it is 36 point. For IB 0.4, it is 36.964. So previously for 0.2 it started at 24. Now for 0.4 it is starting at 36. So that means small change in the active voltage, active region. Okay, so active region is shifted for little bit high current. So now let us go to the 200. Suppose it is to 200, it is 74. Okay, 200 millivolt, it is 74. Increase from 36 to 74. Okay, next let us make it 300 here. What is increased to 80? Again increase to 0. This is 0.3 millivolt. 0.4. 0.4, it is again 80 point something. So no worries. From 36 it came to 74. Now now transistor is working in the saturation mode. For 0.5 it is 81. For 0.6 it is something around 70. Sorry, 0.7 it is around 81 again. It is 81. It is 81 again. And for 1 volt it is around 81 again. For 1.5, so stop this and increase this voltage to 12 volt, because the maximum voltage should be 12 volt. Now I can increase the voltage further. So 1.2 voltage. Okay, for last value what we want is 3. For 3 it is 83. So that means now it started from the 34, 36, 74. Then your transistor is in the saturation mode at around 30, 82, 83. It's a very small deviation, no problem. Next, again, what we do is we will change the transistor value. And just it is 0.4, 0.4. Get back to the 0. So it is 200, 0.4 now. Okay, repeat the same thing. So you can see the change in the active region. Okay, so 0. So this is 100, it is 35, around 39, then 0.2, it will be around 70. Now the transistor is in active region. Again, change the value to 0.3, it is 82. Again, change it to 1 volt, it is 83. So now the transistor is working in the active region. So here we complete the software part for the transistor output characteristics of the transistor. Thank you for watching. You can tab these values in the tabular form and you can submit the reports. Thank you very much.